Hey, and welcome to my YouTube channel. Thanks for stopping by. This is the first video in a series of videos I'll be doing in which I'll be solving LeetCode challenges with C#. And the reason why I'm doing this is because I want to improve my C# skills, and hopefully I can help other people that want to improve their C# skills as well with solving these challenges. So let's get started with the very first problem being TwoSum. And if you're new to LeetCode and you want to follow along, and you see that it's like C++ or some other language here, you can always click this arrow right here for this drop down of the different languages that LeetCode supports for their challenges, and click C# there. It took me forever to find that myself, so don't judge me too hard. So let's begin by reading the description of this challenge. So given an array of integers called nums and an integer called target, return indices of the two numbers such that they add up to target. So let's look at this example. Example 1. Our input are nums, which is an array, and in this test case specifically, an array that contains the values 2, 7, 11, and 15. And our second input is going to be a variable called target, right here. Target of type int, which is set to an integer of 9. Our output is going to be a new array with values 0 and 1, and that is because nums at 0, which is 2, plus nums at 1, which is 7, equals 9. So we return a new array with those the values of their indices. 0 and 1 because an array in C# and in some other languages, arrays are zero-based indexing, hence why the very first number or value in an array, I should say, is at index 0. And same thing for example 2 and 3. 2 plus 4 equals 6, therefore we return a new array. First value is 1 because 2 is at the value of index, I should say 1, and the second value of the output is 2 because 4 is at the index of 2 in the input array. So my first thought process when working with any collections, in this case an array, is if we want to access any sort of value within this array, we're going to have to iterate through it or loop through it. So I'm going to use a for loop. And if you're not familiar with for loops, or if this is your first time seeing a for loop, or if you're new to programming and you're just starting out and you want to learn some new stuff, then I'll explain. I'll break down this for loop for you. So I'll write a little comment here, which is denoted. You can do that by using //. So a for loop is denoted by the keyword for, and within this for loop signature, you have three individual components right here, right? The first one being our counter variable, the second one being our conditional statement, and our third one being our incrementation. In this case, you can also have a decrementation if depending on the use case, but in this case I'm incrementing, denoted by the ++. So we first initialize a variable called I, which is pretty standard. Set it to equal 0, and with C# you have with types being with type safety, right? Strongly typed language. Denote what type you're using, so integer. The second statement here is I is less than nums.length. What does this mean? Essentially, this means as long as the value of I is less than the length of the array. So in this test case, the length of the array is 4 because you have 1, 2, 3, 4 values. And you can also say, with indexes, it'll be at the index of 3 because 0, 1, 2, 3. So as long as I is less than the length of the array, so the length is 4, 0 is less than 4, which is true. So as long as this is valid or true, this code block is going to be executed. So this code block is executed, it exits the for loop, and then we hit this incrementation step. Essentially, this step is I plus 1. So then this I is no longer 0. This I is 1. And then this is reevaluated. So is I less than the length of the array? So I is 1. and 1 is less than 4, which is true. So then this code block is executed again, and then we increment again. I is now 2, and so on and so forth until this is no longer a valid statement. So right now we're just iterating through this array. We're looping through it, accessing each individual value as it increments. But with this challenge, we want to have some sort of comparison, right? We want to compare this value with this value. We want to compare this value with this value if need be, and this value with this value if need be, right? And so on and so forth, until every value is compared with itself. Well, more like each value is compared with each other. My apologies. In order to achieve that, we can use a nested for loop. So a for loop inside a for loop. So our second for loop will be int j equals I plus 1, and I'll explain why I'm using I plus 1 instead of just hard coding the value 1. In a second, we're going to set it the conditional, the same thing as the parent for loop, and we're also going to increment this this inside for loop. So the reason why I did j equals I plus 1 instead of just having it hard coded to 1 is because we wanted it to be continuously comparing neighboring values in this array. Eventually, like we saw a couple minutes ago, this I will eventually turn to 1. And if I is equal to 1 and j is equal to 1, then nums at I and nums at j is the same value, meaning that it's going to compare 7 to itself in this case, which is not what we want. So in order to avoid that, and to always have a staggered comparison, we always need to make sure that j is always one step ahead of I, right? So now that we have this, we're going to have a staggered comparison of each value within this array. So now we are ready to compare whether or not, nums at I plus nums at j is equal to target. And we're going to do that by using an if statement. If nums at I plus nums at j is equal to our target. And I'm doing, I'm formatting my code like this because it's very along the lines of Visual Studio. I'm very used to that with C#. And to me, it makes it a lot easier to read. So if this statement is true, then we found our target. We found our indices that we need to store within this new array, right? And we can do that in C# by using the return statement or return keyword. And then we use a new keyword to instantiate a new array, which will be of type int. And within this new array, we're going to store the values of I and j. And we're doing that because if nums at I and plus nums at j equals our target, then we have the correct indices that is required by our definition here, or description here, right? So we can try running this code. And we're getting an error. Not all code paths return a value. So essentially what that's saying is that, say if, the target was 200, right? None of these values are going to, equate to 200. So in order to mitigate any sort of edge case or test case that results in, no, solution being found, we're simply going to return an empty array. So make sure you're outside of this nested for loop. You're going to return new int and set it equal to 0, essentially saying that it's going to be returning an empty array. And we're going to run it. And it's accepted all 3 test cases. So you could submit this, you could keep it, but if you scroll down on the description of this particular problem, there's a follow-up section, and the follow-up section asks, can you come up with an algorithm that is less than O of n squared time complexity. So if this is your first time ever hearing about time complexity, you can type in something called big O notation, right? And essentially, looking at the Google definition, big O notation is a mathematical function used to determine the difficulty of an algorithm. It defines the time it takes to execute an algorithm, and it will also help you determine how your algorithm's performance will change as the input sizes grow. Right, so it might not really mean much right now with these fixed sizes being 4, 3, and 2, but imagine if you had an array that had a fixed size of like 1,000,000 or 2,000,000,000, right? Some insane large amount. With nested for loops like we have here, it is going to be O of n squared. So you can see over time how, according to FreeCodeCamp's big O complexity chart, it is horrible, right? It just gets slower and slower and slower. And the optimal or excellent is going to be O of 1, which is constant. And what is constant? Essentially, we've already seen it with nums at index 0, nums at index 1, right? Right. You're going to a immediate index within this array. You don't have to do any sort of loop, any sort of iteration through this long array. You're going straight to a particular index to get a particular value. And with C#, you can accomplish this with a dictionary, right? A more efficient solution involves using a dictionary because a dictionary will store previously seen numbers, and we can look at it. We can look at a popular thing to do, a very common thing to do, is look at the official documentations in Microsoft for C#. So looking at the Microsoft docs for a dictionary, we scroll down to the remarks section where they have a definition of a dictionary, which is the dictionary generic class provides a mapping from a set of keys to a set of values. So essentially key value pairs. Each addition to the dictionary consists of a value and its associated key. Retrieving a value by using its key is very fast, close to O of 1, right? Just like we've seen here with O of 1. So that's what we're going to want to do, is use a dictionary in order to achieve this optimal solution, right? So to start, we have to declare and initialize a variable to that of a dictionary. So to do that, we're going to write dictionary. And just like we've seen in the docs up here, you can see it. There's two inputs, right? We're going to make them both integer because that's what we're working with here. I'm going to name it num index map. Excuse me. And we're going to set this to a new dictionary. And essentially what this does is it's instantiating a new dictionary for us with C#. All right, so we've created our variable that's a dictionary that holds a type int for the key and type int for the value. So our key value pairs, this can be very useful. So just like we did before in our first solution, when working with collections, we could still use a for loop. It's not gonna be detrimental using one for loop. But once you start nesting them together is whenever you start getting that O of n squared time complexity. So we're going to use a for loop just like we did before. Int I equals 0, I is less than nums.length, I plus plus. Right? So looking at what we have now, this for loop, just like before, we're able to access each individual value of this array regardless of the array's length, right? The array can be a set of 4 values, it can have 1,000,000 values, and it'll iterate through each and every one value as long as I is less than that length, right? So what we're doing before is that we were comparing neighboring values, right? But with one for loop, you're just getting singular values. So how could we, compare values without having to use a nested for loop? And the way that we can do that is looking at this equation here, right? nums at 0 plus nums at 1 equals 9. So what do we have now, right, is what we got to ask ourselves. Right now we have nums at 0, and we also have our target value. The only thing we don't have is our nums at whatever, the second index, right? So an easy way to think about it is that if we take this nums at 0 and we subtract it from this equation, we'll be left with nums at 1 equals our target minus nums at 0, right? So we can do something like this. Int complement equals target minus nums at I. And essentially, that's what this is a complement, right? As long as, if 9 minus nums at 0 equals nums at 1, then we found these two values that equal our target, which therefore we found the correct indices to store in our new array that we will return, right? And to check whether or not that is true or not, we can go back to our Microsoft documentations and scroll up right here to this contains key method, right? You can click on it and see a definition. Determines whether the dictionary contains the specified key, right? So we're going to use this method. So if num index map contains key of our complement, just this, right? So this line, right? This line right here, it checks if the num index map dictionary already contains the complement as a key. And if it does, it means that we found our two numbers whose sum equals the target, right? So if we found the two numbers whose sum equals the target, that means we have the indices that we need to store in that return array, right? So just like before, we're going to return a new int array. And instead of storing I and j, right, we have to think about what we have right now, right, which is our dictionary and this current counter variable, right? So, if a complement is found in the num index map, right, we're going to return this array containing the indices of the two numbers in the nums array that add up to the target. So we're going to do that by setting our first value in our new array, or our return array, to that of num index map complement. And what this means is it provides the index for the first number, and their second number is going to be I, which provides the index of the second number. And always don't forget your semicolon with C#, right? So that's if it contains it, right? If our dictionary contains that key. And if it doesn't, then we need to write a line of code that if the complement is not found, that we need to add the current key with this corresponding value, right? So to do that, we're going to do num index map at nums at I equal to I. Essentially, we're going to get nums at I, right? So if we break this down a little bit more, nums at I. So for instance, nums at 0, which is 2, which is going to be our key. So index map 2 is equal to 0. So our key, right, is going to be the value of the index in this array, and its value, right, key value pairs, is going to be that of the current index it is at, because this counter variable is counting the indices inside of this array, right? So if our dictionary does not contain the complement, right, then we need to make sure that we are storing that key value pair within our dictionary if the complement is not found. But if it is found, then we found our essentially our two values that add up to the target. And again, outside this for loop, we don't want to forget to return an empty array just in case if the test case doesn't have any sort of values that add up to the target. So again, return new int 0, and let's run this bad boy and see what we get. And we get all 3 test cases passing. So if this was helpful, you learned anything new, comment down below, give it a like, and I'll see you guys in the next video.